Welcome back, everyone. Let's continue with our amazing talks. Our next presenter is Muthu Ramachandran, a research consultant and visiting professor at AI Tech and 45 Tech. Blockchain applications in healthcare have grown rapidly, and it includes record keeping, clinical trials, medical supply chains, patient monitoring, etc., where blockchain characteristics are needed to improve safety, privacy, and security. Muthu, the stage is yours.
Thank you for the introduction. Welcome to my presentation. So it's good you are here because I'm going to give you a lot of questions to ask ourselves and discuss and invite collaboration, because this is very challenging. I mean, 30 minutes I can't cover because I'm both an educational consultant and research consultant. So I have included a lot of my background slides, which I might skip due to the time constraint. But there are lots of challenges because the technology is booming one side. The interest in healthcare emerged from helping my colleagues in a hospital emergency department, NHS in Sheffield in England, because they have to prove to NHS authorities how much every year they have adapted some improvement in the emergency department, because emergency department is collapsing in the UK. They can't handle the number of people. So there's a big challenge. So I help them to emerge a quality framework to demonstrate how much they can improve, identify the existing issues and how they can improve. That interested me to look at healthcare since then. So then I was a speaker last time on AI, ethics of AI. So then I was working parallelly on blockchain. So combining AI and blockchain has a great potential, but there is a lot of issues to handle, because especially if you are adapting to healthcare sector, there is a lot more care to be needed. So therefore, I worked out there should be a systematic approach if we are really peacefully applying the emerging technologies. So we need a framework. A lot of literatures I looked at, they all, yes, is good. Technologies emerged which can be adapted to healthcare to improve the efficiency of the IT. IT in healthcare sector, lot speaker also provided a good overview, especially in the UK, is very, very in bad situation. The government spent billions of pounds last 20 years, I could remember. Nothing was satisfactorily delivered. So now the UK government has invited an American company, Plantieri, something like that. So they initially got involved with the NHS for £1, basically. And there was a surprise why this company is interested in £1 consulting for NHS. But now they won £1 billion to revitalize IT sector in healthcare. So there is a big, huge challenges. So I'm handling 3 topics: AI, blockchain, and healthcare. So let's see. At least we understand some of the challenges. So I put down motivation. It emerged. Blockchain has a great opportunity for us to number of areas, patient monitoring, medical supply chain, and so on. And then, however, we need a systematic approach. Otherwise, we can't rely on the technology alone. So I'll just show how all these areas can be emerged. So software security engineering, cyber security, also to be considered seriously, because it's a patient record, patient information. So there is a great lot of issues that need to be handled. So I have developed what we call a sustainable, secure software engineering framework, which might help us in adapting 50 years of success in domain engineering. I don't know if you heard of domain engineering. Ontologies was mentioned in the last speaker, because these are all well-established techniques to really invest in understanding the healthcare basic background need and so on. So there is a YouTube video which I'm not going to play. Again, if you go to Google or in YouTube, exploring intersection of AI and blockchain, there's a quite introductory concept how both technologies can help healthcare sector. So you can see the global market in blockchain, although there are issues in cryptocurrencies. So blockchain is not just cryptocurrencies, although there are issues that has been identified. But the growth in blockchain is going up. You know, that's 2027, it's predicted by Gartner, 1.18 billion or so. And you can see by sector investment by Gartner. But mostly people are investing on customer-facing relationship. So that's where AI can help, because AI established, like generative AI, chatbot, quite popular, established in other sectors, you know. So why can't we explore those well-established techniques? Again, in my last week, I identified how number of AI algorithms that are successful, because which is not, again, published, the experience, you know, which algorithm to choose. So there is some studies that can help us, especially in the customer-facing area, that can help. You know, patient is like us at home midnight. You can't call NHS or your hospital. So chatbot can help a lot in those situations when you are desperate off time. Yeah, and that's where the NHS is facing difficulty to meet customer needs. So that's one of the area that I identified from existing literatures, both in the success of AI applied in customer-facing applications, at the same time blockchain, how it can adapt securely and in a sustainable manner. So these are two things. So I'll skip current projects. You can connect me on LinkedIn. So there's quite a number of projects. One of the biggest achievement in blockchain, so I'm not going to go through the introduction. So simple definition of blockchain, in case we are not sure, it's a decentralized autonomous blocks. That's the basic simple, and it's difficult to you know, change the state. That's the simple definition. But the key concept in blockchain is what we call smart contract. In other words, the smart contract, one of the other big challenges, the governance and the regulations on healthcare, it varies from region to region, countries to countries. Now, it's at the moment, currently you are checking against the regulations, whereas smart contract can help us to build those regulations autonomically. That's the great beauty of having blockchain integrated into applications. So AI alone cannot help, whereas blockchain has the advantage of giving the regulation autonomically. So therefore, if you are using an app from, say, Serbia, accessing NHS in the UK, help in case of I need immediate care, the smart contract can help, can check the regulations of Serbia, and it can also enable to check the UK's regulations. What is my allowance, you know, if I need to be carried in an emergency situation. So instead of you making phone call here and there, this can be more autonomically done. So this is the example, beauty of smart contract in blockchain. Okay, so I think the financial investment in blockchain is growing up. I mean, a lot of people made money, a lot of people lost money as well. There are incidents. So I think that's another. So the lot of simple definition is it's a decentralized autonomous blocks. That's the simple definition for a blockchain. So how it looks, you know, there's two types of node, the minor node, normal node. You cannot change the state of the normal node without minor adapting the proof of verification. So that's where the blockchain helps us in to secure. So again, another example, in a centralized organization, again, another difference between cloud and blockchain. Cloud is still centralized. That's the problem. That's where the problem comes. Whereas the blockchain is decentralized. So you don't know, you don't have a central control. Instead, each node control itself. So that's the advantage that we can take. Again, number of ledger, that's another concept that can help us in blockchain. So I'll just have to, number of introduction I will skip. So distributed system, consensus mechanism, and agreement. So those are all part of smart contract, where we can encode the rules and regulations, which can automatically map onto your functional blocks. Okay. So again, the key characteristics of blockchain. I'll just sip of water. So that's where it's immutable application of blockchain. Again, in a lot of areas, but for us, we are interested in healthcare. Let's look at number of applications that already exist: smart grid, smart energy, healthcare, transport systems, because we want to create a smart city, both international level, voting, financial system, data centers, especially land registry is going to be the key achievement of blockchain, because there's a number of developing countries, there's a lot of issues in terms of land registry, because you can change someone's property into your name quite easily if you have money. So those are the instances where now even a lot of developing countries are interested in adopting blockchain, because you can't change the state of the block. So there are key advantages in supply chain, transport, logistic, e-government applications, and healthcare. So there are this is one of the combination of the technology, how it can help us. IBAC, simple term, if you can remember IBAC. Internet of Things, what we access from our mobiles, could be a sensor at home. I was working on a European project some years ago, how to help elderly people at home when they are on their own, how technology can help, when they, especially a lot of deaths by falling in their own home is across the Europe. So there was, we developed with the Portugal and other Spain, for people at home, especially elderly people who are alone, how sensor can help, body sensor and various things that it can help to trigger in case of they are falling down, to help local healthcare assistant to come and help us. So this is the, again, huge problem. So Internet of Things, blockchain, AI, and cybersecurity. This is the key, takeaway, for example, message that's going to revolutionize our healthcare system. So again, there are a number of security issues. That's where the smart contract will help us to prevent those issues. So simple concept of blockchain diagram, if you like, you have event triggers and the rules. This is where you can embed your regulation and rules. Whereas I was also teaching at LSE, they are concerned how decentralized organization can take over their legal system. So I'm going to, as I said, a lot of challenging to think. So the legal community is really concerned, because you are taking away the lawyer job by smart contract. So that's a big challenge for the legal community. It's still ongoing. So there is a sustainable and securable. So sustainable goals, again, key message from United Nations. How can we achieve sustainable development goals? How blockchain can help us in that sense. So it's not only energy saving, how repeatable the quality of the function in the blockchain. So that's another concept. That's where reusable blocks also will help us in terms of achieving productivity in blockchain application development. So there's 2-3 concepts intermixed. Again, more challenges, as I promised. All I'm going to give you more challenges to think. How scalable processing time, energy, storage, regulations, how we going to encode different regulations across different nations, especially in the US. Each state has their own regulation. There's a California consumer law and so forth. So that's going to be a huge challenge in the US market because there is regulation across different states. So this is again another interesting link, rule of code versus rule of law. So this is the big challenge for legal community because they are really concerned how decentralized autonomous organization, DAO, is a simple term, how that can take over the legal process. It's a big challenge for them to think. They are really, really worried. They are working hard in terms of looking at DAO and how it's going to affect them. So that's interesting. So let's look at in healthcare how we can build sustainable, secured healthcare applications with a proper systematic engineering principles that has been established 50 years ago. We've been successfully adapting in a number of other areas. So how we can adapt in healthcare technology. So if internet is for connectivity, blockchain is for trust. That's another takeaway. Yeah. So that's where blockchain comes. IT recognizes the feeling. Blockchain remembers what's going on. You can trace back. AI helps us to think. Cybersecurity can protect us. So that's where the combination of the areas. So again, reasons why AI in blockchain, there's quite a number of issues that can be handled. Again, why blockchain for AI? You can see privacy, security is the issues in the AI community is facing. How their problem is privacy. AI can't help in terms of privacy and other issues, bias, algorithm in bias. There's big, huge issues are there to be addressed. So that that's a big challenges in the AI. So blockchain can help in those circumstances. So integration of AI and blockchain, simple diagram. You can see you can build secure, scalable blockchain, privacy preserving personalization. So privacy can be tackled with blockchain because that's the big, huge issue in the AI. So that's where the integration comes in. Coordinating untrusted devices, which we had in the previous talk as well. Enabling AI, how blockchain help us. Decentralized computing for AI, secure data sharing and marketplace for AI. Because one beauty is that with the blockchain service contract, you can also switch which AI algorithm is suitable for you based on your encoding principle. At some time linear progression, you might switch to, if it is not efficient, you can switch to reinforced learning. So that seems to be, reinforced learning seems to be the top secured algorithm so far in the literature, in the practice. So you can switch depending on your taste, what type of algorithm that you prefer, you can encode them in the blockchain. So these are the advantage of integrating AI and blockchain. So in healthcare, what are the areas, how it can help us? See, diagnostic treatment emerged from 60s. Stanford University invented rule-based expert system. I know if you know, MySyn. So simple rule-based, okay, if you have a symptom X, diagnosis Y, that's what the doctor do. Okay, you have a symptoms, and then they predict what the appropriate treatment. So AI definitely can help us. It's been quite successful. So treatment and diagnosis, and moreover, it can predict what kind of disease might occur. If we had last 5 years, at this time of the year, we had a type of flu. I mean, this is where help us, the pharmacy department, to invent new medications. We have been through COVID, so we faced the reality and how AI can help us in those circumstances. The medical researchers as well. Natural language processing, I think, as I mentioned, hugely successful now. It can help us in the front end. If you are alone, even at times where you are not access to the healthcare, you should be able to take some autonomic health advice, symptoms to protect you. So the NL, natural language processing, help us in the clinical area, in the customer-facing area, chatbot, rule-based expert system, example, MySyn. The biggest challenge is the electronic health record, because that's where all your data is mapped, and how that data can help us to do prediction and treatment, diagnosis, everything can be done, because your history of your history is there in the health record. For example, still it's quite impossible for me from one hospital for my treatment to access my data in other hospital in the different region, just close by. I'm from Leeds, Yorkshire. Harrogate is also in Yorkshire, but it's in West Yorkshire, North Yorkshire. I'm in West Yorkshire. That NHS cannot retrieve my data, even today. And when you go to the doctor, I don't know your diagnosis, your image that was done in Leeds. I feel, because I'm an IT software engineer, and I feel very surprised. We are in the 21st century, we can't access your data just from Leeds to Harrogate, which is only 20 minutes drive. So it's a big challenge for NHS. They are doing it because your data protection, but this is where the issue comes. So in number of areas, physical robots, we've seen in the COVID times, even in the airport, robot was delivering sanitaries and various issues. Clinical robots is already there are 2,000 robots, physical robots worldwide. Surgical robots, again, about 2,000 in the US hospitals. It's already in place. Some of the difficult surgery that human can make mistakes, whereas AI robotic application can help us in those. Patient engagement, adherence applications, administrative applications, also a number of areas. So these are the number of areas where AI can help us, but AI has issues of privacy. That's where blockchain can step in. So this is where the integration helps us. These are number of companies already working on blockchain for healthcare. So there's evolution of like Industry 4, if you heard of, in the manufacturing framework, Industry 4. There is also similar framework, Healthcare 4. Now we are into the Healthcare 5 framework, because integrating all those existing technologies, how it can, I think we already discussed the benefit of blockchain to healthcare in terms of decentralized autonomous organization, tackling regulations and legal aspects autonomically, improved data security, privacy, health data ownership, availability, robustness, transparency, trust, and data verifiability. So this is all where how blockchain help in healthcare benefits. So this is the framework, evolution of healthcare framework for. Healthcare 4 combines cloud and fog at present. Now, as I mentioned, cloud is centralized, so we have the same issue. So therefore, we need to evolve to Healthcare 5, which combines IBAC, as I mentioned, Internet of Things, blockchain. There is another technology is emerging, what is called digital twin. So because we can't always trust the autonomic rollout of blockchain and AI, if you have a digital twin, you have a replica of the same technology where you can manually control. So this is another area is coming to help us in terms of digital twin. So for Healthcare 5 framework, we need Internet of Things, digital twin, blockchain, and again AR, VR, again the augmented reality that we have seen some of the applications in the corridor. So that can help us remotely monitor. If you need a lack of health expert, you can adapt the AR and VR technology to help in those circumstances. So let's look at, as I mentioned, the technology exists, but we need a systematic approach because it's a huge investment. We need a much more systematic, robust process and framework to prove to the community. So there are again number of blockchain software engineering for blockchain, compliance and regulation, ethics of AI and blockchain. That's another area again. And the legal community, as I mentioned, they are really concerned because autonomous autonomous decentralized organization is going to take over their job. So this is the framework that I've evolved. There's a requirements engineering, generally. Spend more time on identifying the requirement, elaborating the requirement. You can adopt a number of established techniques in the requirements engineering area. So then there is some design methods. There's a blockchain UML, Unified Modeling Language, which can be adapted as a component, reference architecture, and then tools and number of applications. There should be also adaptation model, looking at the health sector needs and adaptation model. So a simple example of requirement engineering, it can help us through clearly identify the functionality and non-functionality so that you can encode them in the smart contract. So these are the number of requirements classification, again, how you can go step by step in identifying, applying characteristics. Okay, so this is the process for adapting a secure requirement engineering. There is also, I've evolved again from well-established complexity of blockchain, because we need to know before developing how complex the system is going to be. Yeah. So there is a measure. You can count number of blocks. I call it block points, and the human month it might require, and multiplied by human months, a constant based on the cloud. This again well established, based on a COCOMO model. The development time, effort, number of development engineer required, so you can sum them all. Also there is this technical complexity factor and the environmental complexity factor. Based on your environment in which it's going to operate, you can adapt them. So that way you get a clear idea of how complex your blockchain is going to be on the fly. So these are the non-functional requirement if you've done software development, traceability, interoperability, scalability, integrity, confidentiality, CIA principle of security. So for each requirement, you have to adapt CIA principles, yeah, to achieve. Okay. So I've been working with this visual notation tool known as business process modeling. So you got the requirement, you can simulate the requirements in terms of process and know the efficiency of your proposed process of blockchain. So that's the beauty. It's a simple tool. These are the notations, task, subtask, event, it happening. You can simulate them. This is how it looks. Before development, you can prove and verify and simulate how your blockchain will work in reality. And this is where digital twin also will help. Digital twin is a concept, a simulation of the actual implementation of the real world. So this also can help us. You can see when you simulate the number of tasks it going through, time it takes in terms of minutes, and the completion time in red, and so on. So quickly you can get an idea of how efficient is your proposed blockchain. From, for example, different hospital, you can put them in, this is called lane, a pool, and the lane, you can put different hospital, different even countries to see how long it takes to reach a particular environment. So that's the beauty of blockchain. So then other concept, as I mentioned, a domain engineering, which is a quite useful tool. Yeah, powerful tool that has been well established, but you can classify each minute, fine grain your application by classification. So that's the concept of domain engineering. So again, design method I've put down. There's a more systematic approach. This is component-based development design, well established last 30 years or so. So this is the visual component model in UML. You can design how the blocks will look and so on. So you can connect different parts similar to hardware architecture. So this is the reference architecture for a blockchain. So again, you can I've evaluated using a healthcare, EHR applications. Again, there are two other existing IBM blockchain, and there is a medical chain. So there's implementation environment reference. Yeah, so that's more study. This is an example of smart contract, how you can encode governance and regulation into smart contract. Okay, so I think, yeah, lot to cover. That's evaluation. So thanks very much for listening. In summary, yes, we can help IBAC technology into healthcare, but we need to care for it by adapting a secure and sustainable development. Thank you very much. Okay.
Thank you, Muthu, for sharing your journey with us. Here is your certificate of appreciation for your engagement in DSC Europe.
Thank you very much.
Thank you very much.